And welcome back, one and all, and welcome to all the new subscribers. We've actually reached 250 and it's growing steadily. This is more work continuing on the front buffer. This is some brass angle. It started off, I believe, 5/8. It's got to be milled down to 9/16 per leg. 9/16, 9/16, 1/16. So, I don't know, 15, 14, 1.6 millimetre. And it's got to be milled to two different sizes. It will become apparent why. Standard milling operation. Knock down one side, knock down the other side, and then I ended up doing 4 pieces, 2 identical and 2 with a shorter leg. And the setup is a stack of parallels in the vise, the angle sat on top, and a piece of 1/8 inch stock put behind, so that I'm actually clamping so that it's tight to the front jaw of the vise. Clean all the swarf off, take it out, compare it, repeat and repeat. So that's how it was set up. It just gave a more secure, and I kept it straight, parallel, tap it down onto the parallels, making sure they didn't collapse, which they did several times, and just rinse and repeat. Get them made. These are, it seems strange using brass against steel, but it's what the drawings specify. And you can see on the end of the vise there's one already machined. This is the second one. There are altogether 4 pieces made, and I will show them in a moment in their different sizes, and it will become apparent as to why. But it's all work to do with assembling the buffer beams, getting them ready for assembly anyway. That's one of the short ones and one of the long ones. There's the other one, sorry, there's the 2 short ones and there's the 2 equal size ones. These end up is sandwiched either side of the front valance, which is all part of the foot plate. Similar to that, not quite right. There we go. Get it right. As you can see, the flange on the front of that piece is very low, so of course the brass had to be trimmed back to suit. I'd realised that I had misread the drawings. I thought that there were 2 plates on the front, 2 plates on the back, different thicknesses, 1/16 and 3/16. And it turns out that there were 2 plates on each buffer, a 3/16 and 1/16, so they're put together and they're bolted as a stack to the buffer beams. There is a reason for it. The thinner plate is sort of like the surface one. That one has some 10BA bolts in it to hold the buffer stock, as well as the big nut that goes right through and bolts to the back of the buffer beam. And there's 4 6BA bolts in each corner, and this is drilling the clearance hole, machine down. I did them as a stack. First one was right, so just used it and followed it on through. See, I think that's the second hole. Just a case of moving the parallels, which are there for support. Doesn't pay to drill a parallel, because they're hardened and you're guaranteed to muck up the drill. That's hole number 2 done. These are 6BA clearance, and number 4. So with those done, they were moved. Rather than try and find the centre, I got slightly lazy. I thought, well, if I put a 1/2 inch drill in and centre it and just make a mark, I can drill through and then enlarge it. Setting it all up, I actually found that my 1/2 inch drill was nice and sharp. The steel was relatively soft, and I was actually able to drill through, straight through, with a 1/2 inch hole, and it saved a lot of time, a lot of work. This is setting up to drill the 10BA clearance. There's still a little bit more work to do later, in that they've got to be countersunk, because they're just countersunk screws basically sticking through. Why the smaller holes are in the bigger ones, I'm not sure, but I drilled them anyway. They are on the drawing, I think. But having done the 3 thicker ones, which now gave me a total of 4, doing the 3 thinner ones, exactly the same process, and 6BA clearance in the corners, 10BA in the midway on each face, or each side rather. Just basically rinsing and repeating. It's just showing the making of the parts. They were deburred and then set up and fitted onto the buffer beam. It's all coming together very nicely, as you'll see at the end of the video. A little bit of turning in a moment, and most of the last few videos have been milling, so the next video is going to be something totally different, and it is going to be on the lathe, which is that blue object to my right. At the back, yes, a nice 10 by 22 lathe. About time it was used to make something for Dart. There's a couple of turning jobs that have got to be done. But yeah, get these done. There's a lot of work went into these. I've cut the video back very short, because it was so much work, it would have been downright boring. I think when I started, the video was something like all the clips put together were over 2 hours. Well, I don't want to post a 2-hour video, it would bore everybody to death. Yeah. Anyway, this is onto the valance, which you saw part of in the last video. Underneath, it's done so that the outer face is downwards. The short piece of angle brass rather, is placed on a V block, holes drilled for the bolts. This is the outer one, and there's 2 angle brasses on each one. It's an inner one and an outer one. So drill through. I think there are 5 holes in the ends nearest the buffer, and there's about 5 holes or 6 holes along the top edge. Just a matter of drilling them. These, I think, are rivets. One of the nice things that Great Western did is they used a lot of bolts, and that is repeated in the close scale model, and a lot of the work on the buffer beams is all bolted together, so it makes it nice and easy. Yep, just carry on drilling holes, rinsing and repeating. Brass, nice and easy, nice and thin. So, yep, that's the last one on the edge. With that one done, it will be a case of turning it over and doing the inner angle brass. Rather than set it up and DRO it, I just spot face through. As you can see, this one is now the inner one, and again spotting through the steel valance piece. I can't remember what they call it. It's a hanging bracket, I think. But it is part of the valance that runs all the way along the footplate. There's one at the front, one at the back, and then a long piece in between. It will all become sort of much more apparent. With the piece made, it was clamped to the end of the buffer beam. This is the left hand as you stand on the footplate, and again spot face through the buffer beam, through the two bits of brass, so that it will all bolt together very nicely when it's time to assemble it. Nice and easy with its bolts. I didn't have enough 6BA bolts or nuts, so they will be ordered, and the next video in this series dealing with the buffer beam will be actually assembling them so that they're sub-assemblies ready to bolt to the chassis. That was the piece of turning that I did. I've got a piece of brass, turned about 3/8 of an inch down to 1/2 inch, so that it will actually locate all the plates together, give me a little bit of steady, and then a 5/8 diameter head. 6BA bolt in each corner, and just drill each corner through the buffer beams, making sure they're lined up nicely, and just drop a nut in to make sure they're located and don't shift, just in case there was any misalignment. But they went together very nicely, and you can see one bolt in place. Drill the second hole. I think there were about 40 video clips altogether in the making of this simple little job. A lot of work, a lot of time. As I said, 2 hours of videoing, several days of work. But you'll see the result at the end. Drop a bolt in just to locate, move on, drill 3 and 4. So there we go, that's number 4, just going down. They were bolted in place, the guide removed and used on the other end, which of course will then later be, it's saved at the moment, ready to use on the rear buffer beam. That one, it's very similar but slightly different in that you've also got the rear outer frames, so they're already on the buffer beam. Oh, slightly dry throat, sorry about that. But it's a similar process, and that I will probably just make off camera so as not to bore everybody with having to see all this happen all over again. And there we go. This is the final part that goes to the sub-assembly, and I know it's a bit naughty, an end mill in a Jacob's chuck, but it was light passes in brass, which is nice and soft. So this goes at the top of the buffer beam to support the front foot plate, and it's trimmed to length with an overhang of 3/16, 5 mil, over the 1/8 by 1 inch angles already mounted onto the buffer beam, and so it's a case of milling it to length and then milling a recess so that it actually overlaps that angle iron, and it's just milling it down to allow for it. The coupling hook plate has been bolted on, and the piece of angle of brass, which you saw a minute ago, is currently underneath, clamped in place with an engineer's clamp. Now, there we go, there is the buffer beam ready for the next stage. Thank you very much for your time and watching. Please subscribe if you feel so inclined, it does help the numbers, and see you all again soon, I hope. Thank you very much.